Good day, my wonderful students. My name is Mr. Emode Kingsley. Today I'm going to be taking you students in SS2 the topic reflection of light waves. On the board we have the objectives of this lesson, and the first objective here is that at the end of this lesson the students should be able to, number one, list different sources of light, and number two, discuss the principle of rectilinear propagation of light. Under the first objective, we have a side heading there, which is sources of light. As we all know, light is a form of energy, and this energy brings about the sensation of vision that enables us to see. Now we have two sources of light. Number one, the luminous sources of light. These sources are those that emit and generate light by themselves. Example, we have the natural one, just like the sun, the stars, fireflies, glowworms. Those ones are natural sources of light. And we also include the artificial light sources, such as lamps, electric torch, fluorescent light, candles, and some other examples, just like the normal bulb you have in your homes. Now we have the second sources of light, which is non-luminous sources of light. And these are those that depend on what? The artificial sources of light or the self-luminous sources of light to illuminate them. They only reflect the light from these natural or artificial sources. Example, we have the moon, the earth, a page of a book, a person's face. All these, you cannot see them without light. The next side heading we have is the transmission of light. Under this transmission of light, if you look on the board, you will see different types of materials. These materials are classified based on what? The amount of light that can pass through them. If greater amount of light passes through the material, that material is said to be what? Transparent. But if small amount passes, the material is said to be translucent. And if no light passes through the material is said to be opaque. Then we look at examples of transparent material. We have glass, we have water. Translucent, we have tissue paper, we have frosted glass, which we can also see as what? Tinted glass. Then we look at opaque materials. Example, we have bricks, metal sheet, then wood. Now we have another side heading here, rays and beam of light. How do we define a ray? We say that a ray is the direction or the path along which light energy flows, while a beam is just a collection of rays. Then this beam, we have three types of beam. The first one, we have parallel beam. As you can see on the board, parallel beam, you can see that the rays are what? Parallel to each other. An example is what? Searchlight. Number two, we have convergent beam. Here you can see that the rays come from a particular comes from different sources and meet at a point. So they converge or meet at a point. An example is rays from a hand lens. Then we have the third one, divergent beam. In divergent beam, we have that the rays come from a particular source and now spread out. Just like in your room where you have bulb. That kind of beam you produce in your normal room is what? Divergent beam. They come from a source just like the bulb and spread out that you can now see well. An example here, you have beam from lamps. We'll now go to the second objective, which is to discuss the principle of rectilinear propagation of light. So the second objective we have the retinal propagation of light. And as we can see on the board, this refers to as the phenomenon of light traveling in straight line. This phenomenon is responsible for the following: formation of A. Shadows, B. Inverted images on a pinhole camera, and C. Eclipses. We'll now take them one after the other. Let's look at shadows. We are conversant with shadows. If there is sun, normally in the daytime or in the afternoon, you always see a shadow. You can always tell where the sun is situated. If you are standing this way and you are seeing your shadow this way, no one will tell you that the sun is towards this other way. And if the shadow is here, that means the sun is behind you. Now let's look at shadow. From the definition of shadow, we say that normally shadows are usually formed by opaque objects. By definition, a shadow is that area which light cannot reach due to what? Obstruction of what? An opaque object. Looking at the other side of the board, we have two diagrams here. The first diagram, we produce shadow using a small light source, just like the normal light source you can produce from your what? Torchlight. Now, if this is an opaque object and you incident a light source which has a small point, pinpoint on that opaque object, the shadow that is being formed is usually what? Sharp. Very, very sharp. That means the edges are what? Very, very sharp. The other one, if you use a large light source, the shadow produced will be made up of what? Two parts. As you can see on the board, we have an area that is what? Completely dark. That area is called the umbra region. And we have another area, you can see where I labeled P, meaning penumbra. And this penumbra is divided into two. We have the inner region and the outer region. From the description of the diagram, the inner region receives lesser light than the outer region. So that is all for that shadow. We will now take the next consequence of this retinal propagation of light, which is what? Formation of inverted images by pinhole camera. The pinhole camera consists of a light-tight box which has a small hole made with a pinpoint at one end and a photographic film as the screen at the other end. As you can see in the diagram, this is just the pinhole camera, just a light-tight box. Then there is what? A pinhole made with a pinpoint at this end and a photographic film at the other end where the image will be captured. Now, if you look at the diagram, you see an object in front of the what? The pinhole. And there is what? An intersection at what? The pinhole. A ray from the top of the object and a ray from what? The tail end of the what? Object intersects at what? The pinhole. And an image is formed. And as you can see, this image is what? Inverted. This image is what? Inverted. Now, if this pinhole is very, very small, just like what we have studied in what? Shadows, the image that will be formed will be very, very what? Sharp. But if this pinhole is large, the image that will be formed will be blurred. What I mean by blurred, it will not be very, very sharp. But the amount of light that will enter inside the pinhole camera will be large. But for the one that is what? The pinpoint is small. The amount of light that will enter will be very, very minimal. Now we'll look at the magnification of this image produced. From the word magnification, you look at what? If the size of the object is 2 and the size of what? The image is 4, it means that the image has been magnified by what? 2 raised to power 2, which is 4. Now, from magnification here, the definition of magnification is what? The ratio of size or height of what? The image formed to the size or height of object formed. We can abbreviate this using HI representing height of image and HO representing height of object or even size. Then if we go to the other side of the board, we can also define magnification as the ratio of the image distance to that of what? Object distance. This image distance is abbreviated with the letter V, while the object distance is abbreviated with the letter U. Now, the last formula here again is that magnification is also given as the length of the camera all over what? The object distance. You can agree with me that the length of the camera is the same thing as the image distance. From the diagram we have on the board, you can see I can vary the object distance. I can move this object to the close to the pinhole. I can move it to the other end, but the image distance remains the same because the image must be formed on the screen, and the distance from here to there is the length of the camera. So this length of the camera is also equal to V. We'll now take an example. An example is on the board. An object of height 40 cm is placed 0.8 meters in front of a pinhole camera of length 16 centimeters. What is the magnification and the height of image produced? Just the normal way we normally solve. The best way we do this is to write out our what? The parameters or what the quantity is given. Looking at the first quantity given here, we can abbreviate that using HO because it's height of the object. So we write that our HO is equal to 40 centimeters. The next parameter is placed. That means this object is placed 0.8 meters, and that should be our what? Object distance. So we have that U is equal to 0.8 meters. In front of a pinhole camera of length of the camera, I've said that is also equal to what? The image distance. So I can say right that V is equal to 16 centimeters. Then we'll look at the other two parameters, which are the unknown. The first one is M, the magnification unknown, and the last one is HI, which is still the unknown. Now, we'll check the parameters given. We can see that HO is in centimeters, V is in centimeters, but U is in meters, so you cannot solve. If you solve, there will be a problem. What do we do? Because we have the 2 here, so we can convert this to meters. If we convert U to meter, we'll be having what? That this will be multiplied by 100, so we'll have 80 centimeters. Now we can now solve effectively using our formula to get M. How can we get this M easily? Because I have V and I have U, I can simply solve for my M by writing that M is equals to V all over U. And V is 16 all over U is 80. 16 divided by 80, if we cancel out this, we'll have 0.2. Magnification does not have unit because it's just a ratio of what? The same quantity. Centimeter, we'll cancel out and we'll have no unit here. Now, having gotten our magnification, we'll now get our HI. We can use 2 methods. Either using 0.2 for our M and equate it to HI all over HO and cross multiply. Or we can simply say, equate this to this one here, and we'll have that HI all over HO is equal to V all over U. If we make HI the subject formula, we'll be having that HI is equals to VHO all over U. Now we have that our V is 16 multiplied by HO 40 divided by our U, which is 80. Then finally we have that HI is equals to is equal to 8 centimeters. So the height of the image formed is 8 centimeters. Okay. Take this as an assignment. The first one, with diagrams, explain the types of eclipses. And number 2, an object 50 cm tall is placed 1 meter in front of a pinhole camera with length 20 centimeters. What is the height of image and magnification produced? Do this assignment and submit to this email address fgcpscggclass@gmail.com. That's where we'll stop for today till we meet in our next class. Please stay safe. Thank you very much.